In this video, we're going to look at using the law of sines to solve some side-side angle triangles. And this is called the ambiguous case because a side-side angle problem can result in one triangle, two triangles, and sometimes no triangle. I'm going to add that to this sheet right here. So if it's two triangles, one triangle will be acute and one triangle will be obtuse. So we're going to look at that type first. So when you're given a side-side angled option, you're going to know that it's that type of problem because you're going to be given two sides and an angle, and the angle that you're given is going to be the same letter as one of the sides that you're given. So that's how you can notice that you have a side-side angle right off the bat. So I have big letter A and small letter A, so that angle matches one of the two sides. Okay, so I have angle A, 17, side A, 5.8, side B, 14.3. So I'm going to go ahead and I'm going to go ahead and assume that this could be two triangles, and I'm going to go ahead and draw out the two options of what could be happening here, and we're going to work this out as if we don't know yet that it's going to be two triangles, and then I'll show you where you can figure out if it's one or if it's two or if it's none. Okay, so what's happening here is we have this angle A, 17. Let me draw the acute option first. So you have angle A, 17, which would put side A over here, 5.8. And we'll just let this be side B, 14.3. So that would make this angle B. Okay, so this is an acute angle B, smaller than 90. Okay, here's the other option. Angle A, and then side A, instead of swinging out like this, swinging back like this, and forming this type of triangle, where angle B now is obtuse. And then that side being 14.3, and then this side 5.8 still. Okay, so this is your acute triangle. This is your obtuse triangle. Okay, so you're going to set up the law of sines with what you know so far. You have little a, 5.8 over sine big A, 17, equals little b, 14.3 over sine big B. When you go to cross multiply that, you have sine B times 5.8 equals 14.3 times the sine of 17. Okay, and you're trying to get the b by itself, so you're isolating the sine b. So you're going to divide by 5.8. So that is where this comes from. Sine b equals 14.3 times the sine of 17 divided by 5.8. Okay, so you should have learned at this point that you can't separate an angle from its trig expression without doing inverse. So to type this in the calculator, you're going to type angle B equals the inverse sine of all of this. Or you could go ahead and get that as a decimal if you want to 4 decimal places, and then type it in. Okay, so you have inverse sine 14.3 times the sine of 17 divided by 5.8. Close that off, and you get 46.1. Okay, now keep in mind that sine is positive in quadrants 1 and 2. Your calculator is only programmed to give you one answer, but we know that there's two answers. So our calculator gave us an angle less than 90. Our calculator gave us an acute angle. So our calculator gave us this angle B. All right, so what we want to do is we want to find this angle B. So this is like a quadrant 1 answer. We want to find a quadrant 2 answer, an obtuse angle B greater than 90. So to do that, you subtract the 46.1 from 180. Okay, so you're going to do 180 minus 46.1, and you get 133.9. Okay, so typically when you have two triangles like this, you call one of them B and you call one of them B prime. So that's this right here, B with a little apostrophe. So our angle B is going to be 46.1 and our angle B prime is going to be 133.9. Okay, so far we have found angle B and angle B prime. Okay, because our two angle B's are different, that's going to cause our angle C's to be different. So that's our next step. We want to find angle C for each triangle now. So let's start with our acute triangle. We're going to take 180 and we're going to subtract 17, our angle A, and then we're going to subtract 46.1, which was our angle B, to figure out what our angle C is. So we have 180 minus 17 minus 46.1, and that gives us 116.9 for angle C. For this triangle, for the acute triangle. Okay, do the same thing for the prime triangle. 180 minus 17 minus 133.9. 180 minus 17 minus 133.9. And that gives us 29.1 degrees, and that's C prime. Okay, so right here is how you're going to know for sure that you have two triangles, is when angle C comes out to be a positive number for both triangles. If we didn't have two triangles, if one of these was not a triangle, angle C would come out negative. In other words, our angles are too big to make a triangle. And so when we subtract from 180, we end up with something negative. Because both of our angle C's came out positive, then we do have two triangles. So right here it says, is this value C prime positive? Yes. If so, you have two triangles. If not, you only have one. So we do have two triangles here. Okay, so the only thing left to find now for each triangle is little c. So we found big B, angle B for both triangles. We found big C for both triangles, angle C. All we need to find now is this little side C, so little c here and little c prime here for both triangles. Okay, so if you go back to the law of sines, we can make our fraction out of our c's and cross multiply to find little c. So I'm going to start with the acute triangle first. We can put little c over sine 116.9. And then remember, we always want to cross multiply with the fraction that had the most original information in it. The most original information would be fraction A that had the most given information. So 5.8 over 17. And those two things are the same for both triangles. Nothing changed about A. For both triangles, it was 5.8 and 17, 5.8 and 17, although I forgot to write it right there. So that didn't change. And I forgot to write my sine. Sine 17, not just 17. Sine 17 degrees. Okay, so we're going to cross multiply that. So we have C times the sine of 17 equals 5.8 times the sine of 116.9. Okay, and you're going to divide both sides by the sine of 17. Those are going to cancel. Okay, so we have 5.8 sine 116.9, and then divide that by sine 17. And it looks like we get 17.7 is the C value for the acute triangle, the little c value for the acute triangle. Okay, now we're going to do the same thing for the C prime. Okay, so we have little c prime over sine 29.1, And then we're going to use that same a fraction, 5.8 and 17. 5.8 over sine 17. Cross multiply, c prime times the sine of 17. 5.8 times the sine of 29.1. And then I'm running out of space, so I'm not going to write it out, but you're going to divide by the sine of 17. So 5.8 times the sine of 29.1, and then divide by the sine of 17, and you end up with 9.6 for little c prime for the obtuse triangle. And then when you write these answers out, it would be nice if, since they're all kind of scattered, if you would kind of group them up and say, okay, for my prime triangle, I have b prime is this, c prime is this, little c prime is this, and then have all of those answers in one spot. And then for my regular triangle, b is this, c is this, c is this, and have all those answers in one spot so that it's easier for me to grade when I look at those. But that's an example of two triangles. Okay, and here's another example at the bottom. Okay, this time we're given angle A is 58, little a is 20, little b is 10. So we're going to go ahead and draw this out. So I always seem to put the angle I'm given in the bottom left for some reason. That's just personal preference for me. So 58 there, which would put the 20, little a over here. And then I always put my b here, which would make angle B there, angle C there. So this is my acute triangle. And then my obtuse would look like this. Angle A, angle B, angle C. There's my obtuse B with the 58 here, the 10 here, and the 20 here. Okay, so if we set up our fraction, we have 20 over the sine of 58 equals 10 over the sine of B. Cross multiply. You end up with this. 20, there's actually a step in between here. You have 20 times the sine of B equals 10 times the sine of 58. And you divide by the 20. That's where this comes from. And then B is going to be the sine inverse of all of this. 10 sine 58 divided by 20. So you're going to type in sine inverse 10 sine 58 divided by 20. And it looks like 25.1 degrees. So 25.1 for the acute triangle. Okay, to get the obtuse triangle, remember we subtract from 180. So 180 minus 25.1 gives us 154.9. So that's this one. 154.9 would be this one. And I don't have a ton of room, but 154.9 would be the obtuse one. Okay, now we want to find angle C. Remember, what we're looking for is to see if our angle C is positive. Okay, if our angle C is negative, that means we went over 180 degrees and we don't have triangles. All right, so for the first triangle, we're going to do 180 minus 58 minus 25.1 and see what we get. 180 minus 58 minus 25.1. Okay, we get 96.9 degrees. So we do have a triangle there. All right, let's do the obtuse triangle. So for this one, it would be 180 minus the 58 minus the 154.9. 180 minus 58 minus 154.9. and we get negative 32.9. We went over 180 degrees. So no, we do not have a triangle there. So right here, only one value of C is positive. So we only have one triangle. So this obtuse triangle does not exist. We only have to worry about the acute one. Okay, so all that we have left to find now is little c, this side right here. Okay, so we found angle B, angle C. We don't need these anymore because that triangle doesn't exist. We found angle B, angle C. Now we need to find little c. So little c over sine 96.9 equals, and remember to use the most original information as possible to cross multiply, which would be this right here, little a and big A, 20 over sine 58. Cross multiply, we have C times the sine of 58 equals 20 times the sine of 96.9. And you're going to divide both sides by the sine of 58. So you're going to type in 20 times the sine of 96.9 and then divide that by sine of 58. And I'm getting 23.4 for little c. Okay, so that was an example of two triangles, one triangle. Now, what's going to happen if you run into a no triangle is when you go to find your angle B to begin with, you're going to get an error when you have a no triangle. So you'll know that you have a no triangle off the bat because when you go to calculate your inverse sine or your sine, your calculator is going to give you an error when you have a no triangle. So that one will be pretty self-explanatory.